Now let's look at spherical coordinates and integration. So I have a sphere here that I'm starting with, and you can see I've going to give it some depth. And this is in our 3D system, and I've drawn another one to help because this is going to get a little bit busy. So let's get started. So I'm going to start with sort of a point within our sphere, and let's make it here, right here. And I'll put a little circle to represent this as our point. And we're going to reach out to this point from the origin of our sphere. I'm going to reach out, like I'm stretching right out to the point. And there's my point. And I'm going to circle that point again. I want to label this distance. This distance is rho. So I want to draw a perpendicular line from the z-axis out to my point, and I'm going to dash that. Let's dash it a little bit because this is just to show us that I'm forming a right triangle, and here's my right angle right here, and I have this angle right here, and that is the angle that we rotate out from the z-axis, that rho rotates out from the z-axis to meet our point, and that angle is phi. Oh, and I better be consistent and use red. That angle is phi. So let's think about what we've done here so far. We started at the origin. We could say we start by moving up the z-axis a distance rho and then rotating out an angle phi. Now let's draw a line from the point straight down to the xy plane where this point would sort of make a shadow, sort of to right here. And I'm going to dash this like this. Okay. And I'm going to draw another line from the origin out on the xy plane out to the point on the xy plane, which is the shadow of the point, the actual point above on the plane. And let's dash this line. Now, although R in the xy plane is not part of the spherical coordinates, I'm going to label this so you can see that this actually is R, that this line right here represents R. And so we'll do that in black. This is R. And so if our shadow, this is sort of a shadow cast on the xy plane, if the shadow, when this point was sort of over on the other side here, cast down and started at the x-axis, right? We would have this distance r here, and it would rotate around this way. And so the way that it rotates would be sort of going in this direction. Actually, let's make that a little tighter. And that rotation is theta. Our coordinates for our spherical coordinates are rho, phi, and theta. So let me write them down. They are rho, phi. Let me fix that phi so you can see the line through it, and theta. So we're going to look at these. Rho is the distance from the origin. Phi is the angle that, now let's label these. Let's say that the origin, we'll give it the letter O, and our point, we'll call it P. So phi is the angle that vector OP makes with the positive z-axis. And theta is the angle that R makes with the positive x-axis. So these are our spherical coordinates, rho, phi, and theta. So let's focus on the xy plane, and I'm going to draw a line perpendicular that extends from the x-axis up to our point. So it's perpendicular to the x-axis. So let's see if I can do this. We're going to go perpendicular from the z-axis. This is in 3D, so this is a 90 degree. Imagine that's a 90 degree angle. And I'm going to dash it like that. So what I have here is I have this right triangle here. And if you look at this right triangle, if this is angle theta, and the length of this is r, then we know that this is the opposite side, so that this length, I'm going to write it in black, this length, which represents our y coordinate, is r sine theta. Now I'm going to draw a perpendicular from our shadow point. It's going to be parallel to the y-axis, to the x-axis, forming a 90 degree angle to the y-axis. And let's dash this one too. And we know that this is, this distance here, oops, there we go. This distance here is our x distance, or x coordinate, which is the adjacent side to theta. So this x length here is equal to r cosine theta. Okay. Now what I want to do, because in fact, if you notice, our coordinates for spherical, our parameters for spherical are rho, phi, and theta, but there's no r in them. So we have to figure out what is r in terms of rho and phi. Well, the z-axis is parallel to this line that extends from P down to perpendicular down to the xy plane, right? So these are parallel. And since they're parallel, we know that this angle, right here, and this angle are what we call alternate interior angles. What does that mean? That means that this angle here is also phi. So if we look at this, we can see that we have a right triangle right here. So this is a right angle. And the hypotenuse of this right triangle has a length of rho. And one of the acute angles, here's our 90 degree angle, acute angle here is right here. Now, using the Pythagorean theorem or using right triangle trigonometry, we know that this height, z, let me write this down, that this height right here, and we'll draw a little line, which represents z, is equal to r times the cosine, because this is the adjacent side to phi, of phi. Let me make an adjustment here. This is the r in this case is rho, right? Because it's a hypotenuse times the cosine of phi. And then our distance here, r is equal to our hypotenuse, which is rho, times the sine of phi. Okay, so I'm going to come down to these equations for y and for x, and I'm going to replace r with rho sine phi, and I get that y, this y, is equal to not r, but rho sine phi times the sine of theta. And on this side over here, I get x is equal to r, which is rho sine phi times the cosine of theta. And voila, what I have is how to convert from rectangular to spherical coordinates. Z is rho cosine phi, y is rho sine phi sine theta, and x is rho sine phi cosine theta. So we can use our x, y, and z coordinates to redefine the point in terms of spherical coordinates, which are rho, phi, and theta. So if we look at our limits of integration, let me get my pointer here. Rho reaches out and goes from 0 up to the point, which we could call this capital R. So I can say that rho is between 0 and capital R, and phi starts at the z-axis and rotates down this way. So it goes from 0 degrees to pi, because it will come all the way down to a negative z-axis. So here's our phi, and it goes from 0 to pi. And then the last one is theta, and you can see that theta starts sort of at the x-axis, and if you go all the way around the circle, full 360, it goes from 0 to 2 pi. So these give us our limits of integration. So if we're finding our volume, we're going to have a triple integral. And we're going to look at how to set up this three integrals or triple integral to find our volume using these limits of integration in spherical coordinates in our next video.